All right, guys, we're going to be converting radians and degrees today, and I put some pretty important information down there. We've got some formulas. Radians equals degrees times pi over 180, and degree equals radians times 180 over pi. And then I went and put that we know that pi is equal to 180 degrees, and 1 radian is equal to 57.3 degrees. And on this circle, you'll notice that it is a unit circle, and what I went ahead and did was I went ahead and marked where all the radians are located, and I figured that might just help us out as we're going through this. So notice there are 6 full radians, and of course there is this little piece right here. And that's really important because we know that there are 2 pi radians in a circle. So 2 pi per circle. So as we do this, let's go ahead and look at a couple examples and do some quick conversions. So we're going to start by taking radians. And let's take radians and move them in the directions of degrees. So we're going to go R2 degrees, okay? And let's go ahead and take 5 pi over 4. Now, when I look at something that says 5 pi over 4, I actually, anytime there's a pi involved, I go after the fact that I know pi is equal to 180 degrees, okay? So if I want to convert 5 pi over 4 to 180 degrees, really all I have to do is say, well, 5 times 180 degrees divided by 4. And that should give me how many degrees there are automatically. So let's go ahead and do that. I say 5 times 180 divided by 4. And that gives me 225 degrees. So I can say 225 degrees. Now, with that being said, I know 225 degrees is somewhere right in this location, okay? So let's take 5 pi over 4, and let's just type it in and see how many radians that is, first of all. So we can check our work. 5 pi divided by 4 is approximately 4 radians. So is it approximately 4 radians? So let's count them. I've got 1, 2, 3, almost 4, which the 4th ends right there. So that tells us that 225 degrees, 5 pi over 4 are approximately correct just by looking at the unit circle. Let's go ahead and let's keep on working with this just a little bit more. Now, I could say, let's go to 3 pi and let's look at 3 pi. Let's convert that out. Well, if I look at 3 pi, this one is a little bit trickier because I can say, well, pi is equal to 180 degrees. Okay, so I go, okay, well, 3 times 180. And if I go to 3 times 180, 3 times 180, I can say, well, that is 540. Well, 540 doesn't necessarily line up because that goes beyond 180 or the 360 degree mark. Well, there's 3 pi's, which is essentially 2 pi plus 1 pi. Notice what happens. We go around the circle 2 pi, and then we go 1 more pi. And that brings us to right there, 1 pi. Okay, and that is 540 degrees, 360 plus another 180. Not as clear with the unit circle to figure out directly. Now, I do have these nice little formulas over here, and these formulas can still be used outside of anything that goes with this. So let's see quickly, let's change radians to degrees just using one of these formulas that are in here if you like to use them. So I'm going to use this one where it says degree equals to radians times 180 over pi. Well, radians are 3 pi, so I could say, okay, 3 pi times 180 over pi, but notice what happens. It does the exact same thing we just did. We canceled the pi's and we just did 3 times 180. That's where just knowing that pi equals to 180 is super important and helpful. Let's do just a couple more radians and degrees, and in the next video we'll do degrees to radians. Let's look at 3 pi over, not 3 pi over 2, let's look at 1.8 radians. So this time, let's say 1.8 radians. Right? A lot of different ways we can do this. We know that that is 180. So there's a few different ways we can do this. We can use the formula. We can say, okay, well, let's go degrees equals R, which are our radians, 1.8, times 180. So 1.8 times 180 over pi. Some people love that method. Okay, and I just come over here and I say, well, 1.8 times 180 divided by pi. Okay, and that gives me 103 degrees. Or I can say, well, I know 1 radian is 57.3. And so I could also just say, well, I have 1.8 and I can multiply it by how many degrees there are. So I can say 57.3 degrees. I can say 1.8 times 57.3. And this gives me more of an approximation, but once again, it gives me 103 degrees. So we have the option. If there's a pi involved, I like to go ahead and just take that pi and transfer it out to 180 degrees. If there's a decimal radian, I like to use the fact that it's 57.3 degrees. And then also you have this nice formula right there, degrees to radians. And then also we can always check against the unit circle. 1.8 radians we said was 103. So check it out. 103 is somewhere right above 90 degrees, right in there. And there's about 103 degrees. And notice it's 1.8. There's one and then a little chunk of another. So that gives you a little bit of help with figuring that. And that's how we convert radians to degrees.